All right, guys, let's take a look at solving with substitution. So this works great, especially when you have one of the equations is already solved for a variable. So like this one, the second one is already solved for y. So it makes it super simple to plug that into the other equation. So I'm going to take the first one, 5x minus 2y equals negative 11. And where the y is, I'm going to replace it with what y equals. Y is 2x plus 6. So let's see what that looks like. Where there's a y, I'm going to put 2x plus 6. And everything else I'm bringing down. 5x minus 2 equals negative 11, the whole thing. So the only thing that happened is I substituted the y with what it's equal to. Okay, so now we're ready to solve. So 5x I'm going to bring down because I need to do the distributive property here. I get negative 4x minus 12. Now I can look and see if I can combine any like terms on the same side. And I do have like terms. 5x minus 4x is 1x minus 12. You could just put x if you want to. And now I just need to add 12 to both sides. All right, so I've got 1x equals negative 12 plus 12, 0. Negative 11 plus 12, that's like 12 minus 11 is 1. All right, that worked out nicely. So I have the first part of my answer. Remember, when you solve a system, you're getting a coordinate pair. X is 1, and it's an XY pair. So the 1 goes first because that's where the X value goes. Okay, so now I want to figure out what Y is. So you can plug into either one, but it looks to me like it would be much simpler just to plug into the second one. Y equals 2x plus 6. Well, the x I just figured out is 1. So 2 times 1 is 2. Y equals 2 plus 6, which is 8. So the y value is 8. So the solution to the system is 1, 8. That's the answer to the question. Okay, let's take a look at substitution when it's not quite as straightforward. So here we go. Notice that neither one of these are solved for y. And so if you're going to use substitution, one of them needs to be solved for a letter. It actually doesn't have to be y. We can solve for x first. So we'll do that just so you can see the difference here. We'll solve the second one because again, it doesn't matter which one you solve first. It will work. It's so cool how it works no matter how you approach it in that way. So let's say that I want this to be x equals, I'm trying to solve for x. So I would subtract 4y from both sides. I get 8x equals negative 4y minus 4, right? I subtracted 4y so that I get rid of that on the left side. I could have put negative 4 minus 4y. The order of that doesn't matter. I think I'm just used to putting the variable first from y equals mx plus b form or something. I don't know. Doesn't matter. Okay, divide by 8, divide by 8, divide by 8. Everything gets divided by 8. So I've got negative 4 over 8, which is negative 1/2. That's another story for another day. If you're not sure on reducing that, we do that in many, many videos. Okay, minus 1 over 2, 1/2. Okay, so now I have solve for x. So I'm going to go back to this and with a new color, I'm going to replace the x with what it equals. So 7x minus 5y equals 5. And x is equal to negative 1/2 y minus 1/2. And we don't like fractions. They're not fun, but it is realistic that you're going to have to deal with them. So let's see if we can do this. So 7 times negative 1/2 is negative 7 over 2 y. You're just multiplying across the top and across what would be the denominator. 7 times negative 1/2 is negative 7 over 2 minus 5y equals 5. Okay, so the way that I would solve this from here is I would go ahead and multiply the entire equation by 2, and that'll get rid of the fraction. Okay, so 2 times negative 7 over 2 is just negative 7, and that's a y term. And so that does the same thing here. 2 times negative 5y is negative 10y. And 2 times 5 is 10. All right, like terms. I can combine my negative 7y and my negative 10y to get negative 17y. And that was not minus 17, that was minus 7. Okay. So I added like terms. I got negative 17y. I brought down the minus 7 and brought down the equals 10. I'm going to add 7 to both sides. Negative 17y equals 17. Divide by negative 17. Y equals negative 1. So our system is an xy coordinate. The y value I just figured out is negative 1. And now we just go to one of the equations and we're going to plug in the value that we just found. So 7x minus 5y equals 5. You could plug into the other one. It doesn't matter which one you plug into. Y I replaced with negative 1. So 7x plus 5 equals 5. Subtract 5 on both sides. 7x equals 5 minus 5 is 0. It's okay. We panic when we see 0 for some reason, but that's okay. And we divide by 7, and I'm running off the screen, but x is 0. Okay. So we've got our two values. X is 0, so the coordinate pair is 0, negative 1. All right. That was a lot more challenging than it looked. That problem could probably have been solved a different way, more simply, but sometimes you're told solve it by substitution and you have to show that process, even if there's another way that might be simpler, because you're having to demonstrate you really understand the process. So I think it's a good one just to see that sometimes they can be kind of tedious to solve, especially when you have a fraction. And that's okay. It happens. All right. I will see you next time.